everyone, my name is Piyush Sharma and I am currently pursuing Electronics and Communication Engineering.
Greetings everyone, my name is Ankur Anand and I am pursuing Electronics and Communication Engineering.
Hello everyone, I am Anchit Sood and I am from Electronics and Communication Engineering.
Start.
Greetings everyone, my name is Kanav Nandra and I am currently pursuing Electronics and Communication Engineering.
So, hi everyone, my name is Lakshya Pandey and I'm also in Electronics and Communication Engineering. So, I would like to give you a brief introduction. First of all, I'll say that we are pleased to welcome everyone and thank you for joining us today. Our journey in developing autonomous drones for environmental preservation has been a testament to the power of learning, collaboration, and teamwork. We are thrilled to share our project's culmination with you all. Thank you so much for joining.
Researching similar projects gave us a head start on our own drone, involving a paper on autonomous swarm of drones for industrial gas sensing applications. To conclude, the software and hardware architecture to implement an autonomous drone swarm was presented, with the purpose of mapping the gas concentration of a given volume. Also, a research paper on autonomous drone monitoring, analysis, and countering of air pollution using environmental drones was studied. In conclusion, the e-drones offered a new approach at a large-scale air pollution elimination. Also, the study of papers showed us another perspective on environmental monitoring involving the use of wheeled robots, promising an effective environmental monitoring in identification of hidden points of interest.
Objectives. Ever wondered how we make environmental monitoring smarter and more efficient? Enter our Capstone project, autonomous drones for environmental monitoring. But there's a challenge we need to tackle. Right now, building autonomous drones for this purpose is tricky. They are expensive, and the way we make them isn't always efficient. Our Capstone project has clear goals. First objective, efficient elliptical trajectory for flights. First, we are designing drones that fly in smooth, efficient, and elliptical paths. Think of it like a dance in the sky. Second objective, optimized flight paths. We are figuring out the best routes for a drone, making sure they cover a lot of ground while staying safe and smart. Third objective, smart flight control system. There comes the brain of our flight control system. We are using fancy tech to fuse sensors and estimate the drone's state. It's like giving our drones super smart navigation skills. Our Capstone project is all about making autonomous drones that are cost efficient and super smart in monitoring our environment.
Hello everyone, myself Anchit Sood and today I'll be talking about the outcomes and prospective learning in this project of ours. So talking about the project outcomes, the first one is we'll be having multiple drones orbiting in a fixed predefined path without any human intervention. That means they'll be autonomous. And then while orbiting, the air quality sensors integrated and the drone itself will provide us with real-time environmental data. And then this collected data will provide us with real-time air quality at our fingertips, helping us make informed decisions on how to tackle the problem of air quality degradation. Now, let's talk about what we have gained from this experience. Technical expertise is our first takeaway from sensors to navigation algorithm, everything. Drone operations and flight planning comes next. Then sensor integration and calibration comes because it is not just about attaching sensors, it is about ensuring accurate measurements. Then comes data collection and analysis. Since we are handling large data sets, statistical analysis and visualizing data is very important. Overall, this project provides a platform for learning and skill development in various technical, scientific, and environmental aspects. Thank you.
Designing an autonomous drone involves integrating various hardware and software components to enable the drone to navigate and perform tasks without direct human control. Various components which were used in the project are Flight controller. We have used PICSOC 2.4.8 drone flight controller PX4, which is used to achieve autonomous flight. It ensures that the drone can fly accurately along the predefined elliptical trajectory, maintaining stability and control throughout the mission. Mission Planner. It is a comprehensive software tool that serves as ground control station that provides complete flight control and mission planning capabilities for MAVLink enabled drones. Optical sensors. SO2, NO2, and dust particle sensors were used for detecting air quality index. The output obtained from the above is analogous in nature, which is first converted into digital signal by the help of an Arduino board, and then it would drive an LCD display to give the correct reading, as well as it will be saved in the memory. Other important components which were used are electronic speed controller, which is used to regulate the speed of motor, GPS module for precise positioning of the drone, telemetry module for communication with the ground station, frame and structure. We have used a carbon fiber frame and structure for its strength, weight efficiency, and durability.
So with this, I would like to conclude our presentation. Thank you all for being part of our presentation on autonomous drones. Your presence and support fuel our commitment to creating a sustainable future. Together, we can make a difference. Thank you so much for joining, and I hope this made certain difference in whatever you might be thinking about the environmental presentation. And thank you so much.